install these things in classrooms and labs, like fab labs, for instance, and have them to adopt this and make viable education and implementation of this technology. So the whole point is that you can teach kids, robotics, and then you add that next layer of actually socially and environmentally conscious robotics now. Because we gotta, whatever we build now, we have to think cradle to grave, as we say. Is you want to see how much CO2 is being produced, from cradle to grave for everything that we do, and that would be, a socially conscious way of playing with this stuff. So robots and clean energy, our target, middle of high school, as we originally, it's the best, what we believe is the best STEM education for robotics. It brings in essentially robotics, clean energy, electrical engineering, you name it, it has every piece in there. Because if you talk about how you source the hydrogen, as I'm saying, it is the most abundant element in the universe, but it's attached to things. It likes to be attached to things. So you have to actually take that out and know how you're removing it from certain items so you can actually use it for energy. Okay. So what we're calling on is all these different labs to become essentially hydrogen innovation nodes. Fab Lab San Diego, obviously being the first one, and then we have yeah, where it was a third conceived this project, to give credit to a lot of smart people and engineers that made this happen. So Fab Lab Store is where we're selling it. So the whole project, H2MDK, eventually that's the Fab Lab network globally. So there's labs in Kenya, labs in Afghanistan, labs in all over the world, and that was the whole purpose. Is Katie, you can speak much better to the whole network, I'm sure, at some point if you want. Okay. All right. So these are the basic components. So again, you see the Arduino. That's what actually controls the whole thing. What's happening, and your robotics. So you have all those little inputs, right? You have analog and digital inputs. The analog is good for sensing analog things, right? We're in an analog world, and want to convert it digitally, right? So that's what the Arduino is good for. It can do both of those things. And then this is the fuel cell controller shield. So there's actually kind of some fancy electronics in here, like a voltage regulator and a booster. And basically what it means is it grabs the raw fuel cell power and turns it into something usable and stable, so that you can constantly power something without seeing the fluctuations of what the hydrogen inherently has in its system. So then there's also, what's this down now?